I am clearly audible. There is no noise in the background, I hope.
No, sir, you're clearly audible.
Okay, okay, great.
Yes, sir. You can start the session, sir.
Yes, yes. Ma'am. So, hi. Hello, everyone. Yesterday we were discussing about odd and even functions.
Yes, sir.
Hello. Yeah. So, Ashrita, Omkar, Bhavna, और कौन है? गायत्री, ओमकार, Ravani. Great. चलो सही है. हाँ, so you were there yesterday, right? Yesterday, when like, okay, I'll just share my screen. Just give me a minute. So yesterday we were discussing some of the properties of even and odd functions, right? So while discussing the properties of even and odd function, uh,
Properties of integration also.
yes, yes, integration also we had discussed. So similarly, like when we had discussed integration, so with that we had done that differentiation also. Okay, the properties, what happens when we differentiate an even and an odd function. Okay, so in that I had told you that if you differentiate an odd function, it results into an even function, and when you differentiate an even function, okay, it gives you an odd function, right? So basically what happens is, like, you have a function f of x, okay, that is, let me assume it to be odd. So if you differentiate it one time, that is f dash x, so this f dash x becomes even, right? But when you take its double derivative, so what happens is you are basically trying to differentiate this thing. What is double derivative? सबको पता है ना? What is double derivative? Double derivative means derivative of derivative. Okay, differentiation of differentiation. So double derivative basically means derivative of f dash x. Okay, so tell me, f double dash x, will it be an odd function or will it be an even function? Similarly, what about f of triple dash x? What about
Even,
f
sir.
of 4 dash? It will be f double dash x will
Even.
be even. Okay. Can you please give me the logic? Like, what logic did you use,
Means f
Ravani,
of
right?
1 x is equals. Yes, sir.
Okay, okay. Yeah, yeah. Tell me. No worries. Go
If
ahead.
if we change it in, if we differentiate means we get odd, sir.
Okay, so I guess you had told even earlier. So is your answer even or is your
Means
answer odd now? Final answer.
odd, sir. But fourth one I said even, sir.
Okay, okay. So this is odd. Okay. This is even and this is odd. Okay. So yeah, you are correct. See why it is happening in this way. It's pretty simple to think about. See, I am differentiating an odd function. It is giving me an even function. But when I am taking the double derivative, I am basically differentiating f dash x. Okay. When I differentiate f dash x, I get f double dash x. So basically what happens is when I differentiate f dash x, okay, when I differentiate f dash x, I am basically differentiating an even function. Okay, so I get an odd. When I again differentiate it, I get even. So it's basically something like odd, even, like a pattern. Okay, so alternate patterns of odd and even functions. Fine, fine. So like for example, I take a function. I just for your reference, I take a function f of x that is equal to ln. Okay, ln of x plus under root 1. Okay, this is my f of x. And now I am asking you, what is the integration from minus 10 raised to 5 to 10 raised to 5 of f of, uh, let me take it, 2009 times differentiation. Okay, so it is basically 2000 times 2009 times you will be differentiating it. dx. So can you figure it out? Can you figure this question out? See, no need to worry, okay? Like it is not difficult.
Even, sir.
It is even.
I
Okay,
think
sorry,
so,
sorry.
sir.
Yes, yes, yes. You are correct. You are absolutely correct. I am making it 2002. Okay. I am making it 2002.
Odd, sir, no.
Odd, sir. Odd,
Now,
sir.
now, see, F 2002x basically, like here I am denoting it that it is being differentiated 2002 times. Okay. That is what it means. Okay. So see, f of x, what is f of x? Tell me. Is f of x an odd function or is f of x an even function?
Odd, sir.
Correct. How we have defined it in previous class, right? Right. So
Yes,
if
sir.
you differentiate it one times, it is even. If you differentiate it two times, it is odd. If you differentiate it three times, it is again even. If you differentiate it four times,
It
it
is
is
odd.
odd. So that means if I'm differentiating it even number of times, if I differentiate it, if I differentiate it even number of times, it will give me an odd function, right?
Yes, sir.
Similarly, if I differentiate it an odd number of times, it will give me an even function.
Even
Function.
function.
So tell me, I am differentiating it 2002 times. So is 2002 an odd
Odd,
number or
sir.
an even number? Acha,
Even
Even
2002
numbers.
is an
even,
Even
sir.
number,
because
it's give.
2002 है ना? So how do we
Yes,
check
sir.
if it is even? We
Number.
take the last
Last
digit,
number.
है ना? We take the last number, उसमें 0, 2, 4, 6, 8 होता है ना? चलें थर्ड क्लास में वापस?
Nice, sir.
I get it, I get it. You were actually trying to say odd function, but you by
Yes, sir.
mistakenly said you gave the answer to the wrong question. No worries, no worries. I get your point. I was just joking. So see, I am integrating it from minus 10 raised to 5 to 10 raised to 5. Okay. F of 2002 dx. Okay. So I know this is an odd function, right? This is an odd function. ठीक है, ये हो गया odd function अपना. So tell me, I have an odd function being integrated from a to a, an odd function. इसका आंसर क्या होगा? What is the integral of odd function from minus a to a, where a is any constant, any real constant? कल कराया था. भूल गए? Everyone forgot.
Odd, sir.
Odd, like how can the integration, like integration is a numerical value, na? Okay, no worries. I will just go back to that. Uh, I will just go back to that. I don't know if we had done it yesterday. Here I am. See, this is my symmetry, right? Yesterday I had taught you about symmetry. Just a second, I will share my screen again. You had received yesterday's notes, right? Okay. So this is what we had learned yesterday, right? So see, right side we have odd function, left side we have even function. Okay. Even function was symmetric about y-axis. Odd function had point symmetry, like it was being rotated 180 degree. So I had yesterday taught you that if you take the integration from any minus a to a, where a is any real constant of f of x dx, okay, so what happens is it treats the area above y-axis as plus and the same area below y-axis as negative. So
Negative.
when it adds both the areas, what is integration? Integration is dumb. Okay, integration is a very dumb fellow. What he does is, if he gets minus 5 and 5, he will just add both of these.
Zero, sir.
Okay, so
Zero.
it will be 0, right? So now you know that if you have an odd function and you are taking the integration from minus a to a, Okay, no worries. Okay, so tell me what will be its answer? You have an odd function.
0, sir.
0, sir.
Okay, correct. 0. So this is your final answer, 0. And you know the reason?
Yes, sir.
Okay, great. So with this topic, we are almost about to over, like we are almost about to over our chapter of relations and functions. So just a few more concepts that are remaining. Just so yeah, just a few more properties, or rather say a few more things that are remaining is just the graph of some basic functions. Anyways, we have done those, but just for reference. Okay. So do you know what is the graph of y is equal to sine x? Does everyone know? I hope you must have done it in trigonometry. If
Yes,
not, we will
sir.
be doing it right now. Acha, you know
It,
how it looks, right? You know how
Yes,
it
sir.
looks? Okay,
sir.
great.
It
Really
is
good to hear
like
that.
waves,
Yes.
electromagnetic. It is like electromagnetic waves.
Yes. You are correct. You are absolutely correct. So see, this is my x, this is my y. Okay. Somewhere here it is my pi by 2. This is my pi. See, this is my 1. So it starts from 0. Okay, it starts from 0. Pi by 2 पे 1 हो जाता है. Then pi पे 0 हो जाता है. Similarly, I have 3
0.
pi by 2 over here. So 3 pi by 2 पे कहाँ होता है? -1 चला जाता है, right?
Yes, sir.
3 pi by 2 पे -1 चला जाता है, right? अरे यार, okay, just a second.
Yes, sir.
Okay. और वापस 2 pi पे 0 हो जाता है. It is
0.
again back to 0, right? And the same is being replicated on this side. Just rotate this figure by 180 degrees. So it goes something back like this, comes here, and comes. And like it continues for infinitely many alterations, right?
Yes,
You know
sir.
this thing, right? You know na, or you don't know? अच्छा, ये तो पता ही था, है ना? So
Yes,
similarly, if you know this, you know for y is equal to cos x also.
Yes,
You
sir.
yes,
know
yes,
y is
sir.
equal to cos x.
Sir.
It is almost same. अरे,
Yes, sir.
it is almost okay. Okay, it is almost same. The difference is this curve is starting from origin. Like this curve is passing through origin. It won't.
Four.
It will pass through this one point. At
One.
0, it is 1. Okay. So it is something like this. Go back here, and then top. Similarly, over here, go back here, go back here, like this. So tell me, what is this point? This is pi by 2, right? This is 3 pi by 2. This is 2 pi, and this point, again, where it is becoming 1, it is 5 pi by 2. Correct? This is 0. This is minus
No,
pi by 2. Yes, any issue?
3 pi
It
by
is.
2 is not
Oh,
pi.
sorry. Yes. It will be pi. Yes, you're correct. Okay, so it is shifted actually. Sorry, yeah, it was my fault. Thank you so much. Arey, actually, it wasn't my fault actually. I was just checking your knowledge. That's what most teachers say when they make a mistake.
Yes, sir.
I was checking your knowledge. I purposely made a mistake to check if you are attentive or not. Yes. So minus pi by 2, minus pi. Okay. Sorry, I didn't get you. Can you speak again?
Checking your knowledge, sir.
Right, something like this. So yeah, this is sin x, this is cos x. Okay. Similarly, what about tan x? tan x is bit special. Do you know about that or not?
Yes,
Yes,
sir.
अच्छा
yes, sir.
पता है, चलो फिर तो आप सेफ हो. ठीक है. I'm just trying to make a freehand curve. No need to worry about accuracy. My graph is being scaled. Okay, I'm making trying to make it scale as much as possible. This is pi by 2. This is minus pi by 2. Okay. Obviously, it will pass through this. But now one special thing comes over here. Okay. What happens is
Normal.
it passes through here. It passes through here and like this, एकदम infinite पे चला गया. Similarly, it passes through this,
Yes, sir.
बिल्कुल infinite पे. So if you just remember, I had taught you a term. If you remember, what do we call these two lines? I have this one line, and I have this second curve, y is equal to tan x. So these two curves, they are not intersecting. Okay, they are not intersecting, but they are going really, really close at infinity. They are going very, very, very close
Yes,
at
sir.
infinity. What term
Limit,
do we use
sir.
for that?
Limit,
What term?
limit,
No, they won't meet. They won't meet. नहीं, what are you saying? Sorry.
Limit, sir.
limit.
Limit. अरे नहीं, limit, like limit is for numbers. I had taught you a term for two lines or two curves that go really close to each other at infinite values, but they don't touch. Limit is nothing, like limit is basically a number, just like
E
x
power
is tending to y. So that means limit. But I there is that term is not for no, like curves. If you remember, I had taught you a term by the name of asymptote. If you remember clearly,
is
while we
it,
were plotting of functions.
sir?
Yes. What
Is
do you? Does anyone remember this phrase that I had taught you earlier? Asymptote. When we were plotting earlier functions of e raised to x and ln x. Okay, just remember this term, asymptote. Asymptote basically refers to two curves or two lines that go really close to each other at infinite but never intersect. Okay, that is what asymptote means. So basically, tan x is asymptote to x is equal to pi by 2, x is equal to minus pi by 2. Similarly, again, it will do the same thing at repetitive values of 2 pi. Okay, see, I can show you again. This is pi by 2, na? This is pi by 2. So pi by 2 plus pi कर दो. So it is 3 pi by 2. Just a second. ये है 0 है pi. हाँ, so from here it will start. This is by 2. Just a second. 3 pi by 2 is how much? This is 0. This is pi by 2. This is 3 pi by 2, right? So at 3 pi by 2, I'll just keep my
270.
sign. Yes. 3 pi by 2 is 270. My sign is minus. Yes, so yes, it is correct. Wait a second. Am I making? No, it is correct. Right? Something like this. Yes, it is correct. It is correct. This thing is pi, na? It is pi. Yes, it is correct. I was just verifying my calculations. So see, the point I'm trying to make is this curve is asymptote. This curve is asymptote. Y is equal to tan x is asymptote to what lines? So first I have this line x is equal to pi by 2. Then I have this line x is equal to 3 pi by 2. Okay. Similarly, x is equal to minus pi by 2 also. See, you can see here. These three are lines that are parallel to y-axis. Okay. This is my y, this is my x. Okay. If you look clearly, they are asymptote. Similarly, you just add pi to these values in negative side also, in positive side also. So in general, I can say, in general, it is basically pi by 2 plus z pi, where z is any integer. Okay. If I plot a line, if I plot such a line, x is equal to pi by 2 plus z pi. I plot a line x is equal to pi by 2 plus z pi, where z is any integer. So my y is equal to tan x will be an asymptote to that line. Okay. Got any confusion? I guess there is a bit of confusion.
Yes, sir.
Uh, I knew it. Can you yeah, tell me what is your doubt? First
Can
of
you
all,
explain?
you know, uh, yes, I will. Just a second. Please give me this. Yes. Now ask me, what is your doubt? What do you want me to explain?
About this graph, sir. About the
See,
text
see,
value.
see. Okay, no worries. See, I'm just telling you. See, I have plotted this curve. Okay, I have plotted this curve. I have plotted y is equal to tan x. Okay, y is equal to tan x, and tan x is basically what sin x by cos x. Okay, and if you remember earlier, we had discussed a set of values where this tan x, like the domain of this function, we had discussed. Domain means the set of values that you can input inside the function, right? I hope you remember that. So in that, so in that we had learned that whenever cos x is zero, you can't input you can't input those values of x where cos x is zero, because it will be division by zero that is not allowed. So basically,
Indefinite.
wherever my cos x is zero, I am not allowed to input those values. Okay. So what is happening is, see, I have this value over here. When my x value of x is becoming really close to pi by 2 on the left side. Okay, I'm just assuming on the left side of pi by 2. So what is happening is my value of tan x is growing really high. Okay, sin x by cos x. Okay, and when my x is tending to pi by 2, so what is happening is my sin x has increased, sin x has grown really close to 1, and my cos x has grown very close to 0. So what is happening is it is giving me a very high value that I am assuming it to be infinity. Okay, but at when x is exactly equal to pi by 2, when exactly equal to pi by 2, my tan x is not defined. This is what asymptote means. Asymptote means you have two curves. One curve is this y is equal to tan x wala curve, the one I drew in blue. Okay. The second one I'll be highlighting in red. Okay, this one, this line. I have this line x is equal to pi by 2. This line that is parallel to the y-axis and passes through pi by 2 comma 0. I have this line. Okay. So these two curves are not intersecting. These two curves are not intersecting, but they are just growing really close to each other when my y is tending to infinity. Okay, at infinite large values, they are growing really close, but they are not intersecting. That is what is meant by the term asymptote. So since y is equal to tan x is a repetitive curve, so whatever is happening at x is equal to pi by 2, the same is happening at 3 pi by 2, the same will happen at 5 pi by 2, the same will happen at 7 pi by 2. Okay, whatever is happening at x is equal to pi by 2, the same will happen at 3 pi by 2, same will happen at 5 pi by 2, same will happen at 7 pi by 2. Okay, similarly on the minus side, same will happen on minus pi by 2, same will happen on 3 pi by 2, minus 3 pi by 2, same on minus 5 pi by 2, same on minus 7 pi by 2. Okay, that's it. This is the point that I'm trying to make. you pull a line x is equal to any of these values. Okay. If you pull a line x is equal to c, what is the line x is equal to c? It is something like this, na? This is your line x is equal to c, a line parallel to y-axis. So I am telling you choose your c. You choose your c constant to be any value pi by 2 plus z pi, where z is an integer. Okay. You choose any value of z, 1, 2, 3, 4, 5, 7, minus 11, or minus any value, integer value you choose, and you pull your line x is equal to c. Okay. You choose any constant value of z, you put this value of, you get this value of c, you draw this line x is equal to c, and I can surely guarantee you that my line x is equal to c will be an asymptote to y is equal to tan x at that particular value. Okay. Now you get that what I'm trying to say. I hope it is much clear. Any doubts? If you have any doubts, you can ask.
No doubts.
Are you sure?
Yes, sir.
Okay. See, just what I'm trying to say is, yes, yes.
नीचे का नहीं समझ में आया
किसका?
वो ग्राफ के नीचे का ये सब
ग्राफ के नीचे
ये आप
this part.
सॉल्व करे ना हाँ ये सब
See, I am not actually solving it. I am just trying to show you what is happening is when we were trying to find the domain, of tan x. So I had told you that wherever my cos x is 0, that values I won't be able to put inside. Okay, that values will be removed from my domain of tan x. Domain means the set of input that I can give to tan x. So what is happening is wherever cos x is 0, so I got this value pi by 2, x is equal to pi by 2, where my cos x is 0. So this is the value that I can't put. Okay. So this is the where my this is the point where my function is not defined. But what happens is when I take a value very close to pi by 2 on the left side, okay, assume it as a limit. Okay. Assume it as a limit to pi by 2 on the left hand side. So what happens is my value grows very, very high, very, very high. Like it grows to infinity. I am assuming it is very high now, so I am assuming it to be infinity. And what happens at the immediately next point? At x is equal to pi by 2, it is not defined. So basically, if I take a value really close to pi by 2 on the left side, my function has grown to infinity. And at x is equal to pi by 2, at the exact value pi by 2, it is not responding. It is not giving me anything. So what is happening is it is growing really close. It is growing really close to this thing, this line, x is equal to pi by 2, but it is not intersecting it. That is what the point that I'm trying to make is that it will go very, very close to this curve, but they won't intersect. And that is what we call asymptote. See, and one thing more, y is equal to tan x, it is a periodic function. Periodic means it repeats after time to time. So the same thing that happens at pi by 2, the same thing will happen at 3 pi by 2 also. The same thing will happen at minus pi by 2 also. The same thing will happen as minus 3 pi by 2 also. So that is what we mean by an asymptote. So I just generalized the formula pi by 2 plus z pi, where z is any integer. So you put any integral value of z, okay? You put any integer value of z, you pull this line x is equal to c, where your c is equal to pi by 2 plus z pi. So your x is equal to c will definitely be an asymptote to y is equal to tan x. Fine? That is what I tried to say. You got it?
yes sir
Okay, great. Good to hear. So, okay. So just one thing more to go. Hmm, the comparison between y is equal to sine x and y is equal to x. Do you know this? Comparison, like plotting them on the same Cartesian axis. So this is my x-axis, this is my y-axis. Okay, I am plotting my sine x curve. Similarly on this side. Something like this. Okay, actually it doesn't look like this. It is a bit flatter. Okay, something like this. Fine. This is it. Okay. So this is my y is equal to sine x, the one I drew in green. Now I'll be drawing my y is equal to x on with red. Okay. So what will happen with y is equal to x is it will pass through origin definitely. It will move something like this. This is my y is equal to x. It will go like this. Fine. Got it? Any doubt? So they are just intersecting at one point, and that one point is origin
45
0,
degrees
comma
it
0.
makes.
Yes, yes, correct. It will go at
Yes,
45 degrees.
exactly.
Absolutely correct. Absolutely correct. So see, just mind one thing. If you look at this curve, y is equal to sine x. Okay. If you look at the curve y is equal to sine x, do you recall something? See, I have this curve y is equal to sine x. Okay. I'm just for fun, I'm plotting it like this. I have a curve like this, and I have a line passing through this point. Okay, sorry. I have a line passing through this point that is just
Tangent,
intersecting it
sir.
once.
Tangent to this
Absolutely
sine.
correct. Bhavna, right?
Yes, sir.
Acha, so we have two Bhavnas in the class, I guess. Which one are you? The one who frequently comes or the one who doesn't come frequently? Like, what is your full name?
Sir,
Like,
Kajal
there are
Bhavani.
there are two Bhavnas in the class, I guess. Okay, yes, just a bit. Yes, you are
Bhavana
absolutely correct.
Helli, sir.
Okay, okay. So yes, you are absolutely correct. It is a tangent because it is just intersecting at that point, and I can confirm that also. You want me to confirm? I can confirm that it is a tangent. Why? Take its derivative. So you take both of these curves derivative at x is equal to 0. Okay. So I have this curve y is equal to sine x. Tell me what will be its derivative? What is the derivative of sine x?
My, sir, it
X
is
minus.
Minus cos x, है ना?
no, sir. Cos x,
अच्छा,
sir.
cos x. correct.
Cos x.
And what is the
sir.
derivative of x?
1, sir.
Sir.
1. Absolutely correct. So I am telling you that you put x is equal to 0 here and you put x is equal to 0 here. So tell me, what will be the value of dy by dx when x is 0? In this case, in the first case, you put x is equal to 0 here. What is cos of 0?
1, sir.
Correct.
1, sir.
Similarly, my dy by dx is 1. So at x is equal to 0, what will be the value of dy by dx?
0.
0? My dy by dx is 1. Okay. My dy by dx is 1. It is a constant function. Like it is a constant value. So no matter you put x is equal to 0, you put x is equal to 0.5, you put x is
1.
equal to 1. It
1,
will always
sir.
be 1. Absolutely correct.
1.
Yes.
It has to be 1 because my
Yes.
dy by dx is a constant value. Na? It is constant. You know what is constant and you know why it is constant. Na? See, it is a straight line. So its slope at every point will be same. Slope. Slope pata hai na slope.
Yes, sir.
So its slope has to be same at every point. So that is why the value is turning out to be a constant value, right? So I have confirmed this thing also. Now I have confirmed you two things. with two different methods. See, they are intersecting at 0, comma 0. Okay. They are intersecting at origin. Along with that, they are having the same slope also. They are having the same slope. Same slope भी मैंने check कर लिया. That means tangent. Obviously, has to be tangent. I have a curve. Okay, I have a curve like this. That is y is equal to f of x. I have a line that is passing through this. Okay, and intersecting it at this point. The slope of the curve, the slope of curve is equal to the slope of line. So what can I say? I can say it has to be a tangent. Yes, at that point only. Yes, right. So that means my y is equal to sine x. My y is equal to x is a tangent at origin. At origin to y is equal to sine x. Okay. So basically it is acting like a tangent. Okay. So like this was just a bit about the properties. Yeah. And moving ahead, अब थोड़ा difficult चीजें आ सकती हैं. So just be prepared. Like you will need to visualize basically. See, I just hope you have learned all the graphs till now, that whatever we had taught you, I had taught you. Okay. Till now, there were like somewhere around 9 or 10 graphs we have discussed till now. Mod x हो गया, e raised to x हो गया, e raised to ln x हो गया, something like this. Okay. So there are just a few more properties related to the graphs that we will be discussing right now. Okay, it is difficult just in terms of imagination, not in terms of solving.
सर ये चैप्टर कब खत्म होता है सर?
चैप्टर बस अभी 1 या 2 क्लास ही है, बस जाने ही वाला है. क्यों, नया चैप्टर की वो है क्या? यू वांट टू लर्न समथिंग न्यू?
Yes sir, we are excited for new.
I know you are see, the point is it is very important chapter. Okay, because what I have taught you here ना, like for example अब मैंने तुमको ये पढ़ा दिया y is equal to cos x, y is equal to sin x. So what will happen is when you will learn trigonometry, so I am assuming sir won't need to teach this. Okay, that is why we are just doing it that way. Okay, so there are a few properties related to graphs or functions. Okay, so the first property, I have a function y is equal to f of x. Okay, I have plotted it. I have plotted that function. Something like this it is looking. Okay, however it is looking, I don't care. And now I am trying to plot the function of y is equal to f of x minus a. Instead of x, I am putting x minus a. So what will happen is, what will happen? Can someone say what will happen?
I will
Uh-huh.
move
Guess.
it by k
Correct.
units to k.
A units to right or left?
Right, sir.
Correct. Absolutely correct. Correct. See why? Like it is very easy to think now. Earlier, if you had a value of x, okay, you inputted it, it gave you the value of f of x. Now, if you need the same value of f of x, you will need to put x plus a. Then only you can get the same value of f of x. Okay, very like very easy to think. Earlier, when you were putting x, you got f of x. Now, in order to get the same value f of x, you need to put x plus a here. So my same curve, the whole curve will move to the right by a units. Okay. Second, so see, this a is basically an integer. Okay. So if my a is negative, like if I'm doing y is equal to f of x plus 5, so it will move to 5 towards left. Okay. This a basically denotes like my a denotes sign also. Okay. So treat a as an integer. Treat a as a sign symbol also. Okay. So if I'm telling you to move a curve to 5 units, minus 5 units to the right, It means move 5 units to the left, right? इतना तो पता है ना? अच्छा चलो यार, नहीं पता, चलो कोई बात नहीं. I will write it again. See, I have a function y is equal to f of x, okay? Now I am writing y is equal to f of x plus a. So it is nothing. Move to the left by a units. Okay. Move to the
Yes.
left by a units. See, why we are doing this is like it is the same thing. A and minus a are nothing different. It is just that when you are getting a minus sign, so you will move to the opposite direction. Its direction will invert. मतलब इसमें कोई नया mechanism नहीं है. It is nothing. It is not a new mechanism that we are doing. Okay. It is the same thing. Earlier you were doing f of x minus 2. Okay, so you will move 2 units to the right. Now you are doing f of x plus 2. So you will move 2 units, or rather say minus 2 units to the left. Now you will
Yes, sir.
minus 2 units to the right. So what does mean, like what is meant by the term moving minus 2 units to the right? Minus 2 units to the right means 2 units to the left, right?
Left side.
Displacement. पढ़ा है
Yes,
ना
sir.
displacement? हाँ चलो
Yes,
बढ़िया.
sir. Sir.
Okay, great. चलो. So see, I have a function y is equal to f of x. Okay, I have a function y is equal to f of x, and now I have to plot the function y is equal to f of x plus c, some constant c. So what will happen? My curve will shift vertically
Yes, sir. Vertical
by c units
3 units.
to
Sir, yes, sir.
upwards. C
Sir.
units to upwards. Okay.
Word.
So if I'm getting the value of c as a negative, if I'm getting f of x minus 5, so I will move 5 units to below.
By downwards, sir.
Yes,
Correct,
sir.
correct.
By 3
Yes,
units.
correct. हाँ, yes, yeah, correct, absolutely. Okay, fourth, ये पहले के 3 तो बहुत इजी थे, ठीक है. इट वाज वेरी लाइक कुछ था नहीं खास इसमें. ये चौथा वाला थोड़ा सा इंपॉर्टेंट है, एंड इट इज अ बिट डिफिकल्ट टू अंडरस्टैंड समटाइम्स. I have a function y is equal to f of x. Okay. Now I'm trying to plot the function y is equal to f of ax. A is, I am assuming a to be positive first. पहले केस में मैंने a को पॉजिटिव माना है. अभी अगर a को नेगेटिव कर दिया तो भाई फिर तो मतलब ज्यादा मुश्किल हो जाएगा. चलो बताओ. नहीं चलो ठीक है, उससे पहले एक इजी वाला केस करते हैं. फर्स्ट वी विल डू दैट इजी केस. ओके, तो इजी केस में क्या है, f ऑफ माइनस एक्स है. टेल मी व्हाट विल हैपन. I have plotted a function
It will
f of
be
x. हाँ, it will be what?
Yes, sir.
Sorry?
Symmetric
I,
f of x, sir.
हम्म मतलब क्या?
By
Can you speak?
y-axis, sir.
Sorry?
Mirror image
Like
of
mirror image about what? Like about what?
f of x, sir. About
Huh?
y-axis, sir.
About y-axis. Yes. Absolutely. So I have something like this. So it will just mirror inversion about what line? Can you speak again?
Y-axis,
What?
sir.
Y-axis. That's correct. I thought you were telling y is equal to x. Okay, yes, you are correct. Because like just imagine now, you were earlier putting a value of x and you get f of x. Now, what value should you put to get the same f of x? You will put the negative value. So it will just invert, mirror inversion.
f of minus x.
है ना? So it will look something like this. Mirror inversion.
Yes, sir.
Easy ना? Easy है ना? ये तो बहुत
Yes,
easy है. चलो
Yes,
अगले
sir.
पे आते हैं फिर. हाँ कोई बात नहीं. अभी तो पार्टी शुरू हुई है. हाँ तो आ जाओ फिर, करते हैं पार्टी शुरू. Y is equal to f of x है. Okay. I have another function y is equal to f of ax. A is obviously like I'm assuming it to be greater than 0 currently. अब क्या होगा? पार्टी हो गई? No need to worry. See, I have something like a curve, something like this. Okay. Generally, I just like for easy showing it, I just show it something like this only. So see, what is happening is I have a value x over here. So I am getting f of x. Now, just think, if I want to get the same value of x over here, what value of, like, if I want to get the same value of f of x, like the same value y. So in order to get the same value y, what x should I put over here? Just like think it in basic sense. See, I am putting a value, so I am treating it as y1, okay? Y1 is equal to f of x. I got this function y2, that is f of ax, okay? I am putting any value x over here, okay? I am putting any random value x. So I am getting y1 is equal to f of x. Now what this function is telling me, it is telling me, sir, you get the same value y on both sides. So tell me what x should I put here? What input should I give over here? Can I say that my input will be x by a? You put x by a over here, you will get f of x again. Is that true? My input will change to x divided by a. Is that correct? Yeah, f of ax है ना? So you just put in place of x, you put x divided by a.
Yes, sir.
Yes, sir.
सही है ना?
हाँ
सही है ना?
सर.
तो पक्का ना? देख लो कोई डाउट है तो ऐसे ही हाँ मत बोल देना. See, y1 is f of x, okay? And I am telling you what value of x you should put so that you get y1 and y2 equal, okay? So basically my y2 will be also equal to f of x. So my f of x should be equal to, अरे यार इसको x1 बोल दो, इसको x1 बोल दो, इसको x2 बोल दो. So it is f of x1, okay, is equal to f times a of x2. So can I say my x2 will be equal to x1 by a? x1 और x2 बोल दिया मैंने उसको, ठीक है? टू टू डिफरेंट x है ना? अरे नो नीड टू वरी अबाउट x1 एंड x2. लाइक आई वाज नेमिंग हियर x1 और यहीं पे मैंने उस चीज को x2 नेम कर दिया है. आई एम डिनोटिंग द सेम वेरिएबल. नो नीड टू वरी, ओके? कंफ्यूज तो नहीं होगा इसमें कि सर x2 कहाँ से आ गया? अरे यू कैन आस्क, स्पीक समथिंग प्लीज. Okay, see, like I have a function f of x, y is equal to f of x. So I'm the first input, the input that we were giving, I am assuming that input to be x1. And now the new input that I have to give, I am taking it to be x2. Okay. I'm in order to check what is the relation between my earlier input and my new input. My earlier input and my new input, what is the relation? I'm just checking that relation. So what I'm doing is I'm taking y1, that is f of x1, and it is asking me, sir, what value of x should you put in the second function in order to get the same value of y? So I got y2 as f of a times x2. So I equated y1 and y2. With that, I got f of x1 is equal to f of ax2. So f for f है, input has to be same, right? So that means x2 is equal to x1 by a. अच्छा ये कैसे आया? Okay. So f हटा दो ना दोनों साइड से, just comparing the inputs. So my x1 will be equal to a times x2. So my x2 will be equal to x1 by a. ठीक है? Any doubts?
No, sir.
पक्का ना? Okay. See, like, sorry? Acha, see, what we were doing here is, see, I am just trying to find what will happen to my curve, okay? What will happen to my curve? So what I'm doing is, I have taken this function y of x, y is equal to f of x. I have taken another function f of ax. Okay, I have taken a function f of ax. Okay, f of a, like it is just multiplying. So I'm just checking what will happen to my input. So I'm taking this input as x1 and I'm taking the second input as x2. इसको मैंने x2 बोल दिया, ठीक है? So in order to check the relation between x1 and x2, I am calculating y1 as f of x1, okay? And I am calculating, I am giving input here, I am calculating y from here also. And I'm asking you, what will be the relation between x1 and x2 such that both my values of y are same in this curve also and in this curve also? Like ये curve जैसा भी दिखे, I don't care how this curve looks. I just want the same value of y. Okay, I just want the same value of y. So I am calculating y1 from this curve. I am calculating y2 from this curve, and I'm finding the relation between these two. So in this relation, I found out that my new input has to be old input of x divided by a. Okay, this is what I'm inferring. That my new input, the new input that I have to give, it will decrease a times. It will decrease, like it will be divided by a. So basically, what will happen to my curve is, just try to understand is what will happen to my curve is, curve will shrink a times in x-axis. Like in, okay, so like it will shrink like this. Shrink means it is like someone is pushing the curve from both sides. Just assume that the function is being pushed from both sides in x-axis. Okay, I will give you an example here. See, I have my curve y is equal to sine x. Okay, so I have my curve y is equal to sine x. So this is 0, this is pi by 2, this is pi, this is 3 pi by 2, this is 1, this is minus 1. So it grows from here to here, comes back again here, goes back again here and here. This is 2 pi. Okay, now I am asking you to plot the curve of y is equal to sine of 2x. ठीक है, वही सेम चीज है ax. So my curve should shrink a times. Like it should basically uh, like shrink को क्या बोल सकते हैं? Like you used to do it on vectors, right? If I have a vector a vector and I multiply it by a constant k, so what happens is its length grows by k times, right? Okay, so its length will grow by a times. So similarly, I am asking you to grow, like to shrink the curve a times in only in terms of x axis. My y will remain same. So how will it behave? This is 0. So my points will be divided by 2 now. So this is pi by 4. This is pi by 2. This is 3 pi by 4. And this point that was earlier 2 pi is pi now. And my there is no change in the y axis. Okay, it will just come, like it will come closer a times. So it will be divided by 2. So ये गया ऊपर, back again, back down, back. So like you can see the difference over here, right? You can see the difference. It is my x coordinates are just being divided by 2. My x coordinates have divided by 2. Okay, like it has shrunk, it has grown patla. Earlier it was taking huge space. I should maybe draw it on the same scale to show it to you. Wait a second, I'll draw it on the same scale. Okay. So this is my pi by 2. So this is my pi by 4. This is my this thing and this is my this thing. This is my 1. ये तो 1 तो मैंने पहले भी लिया था. This is my -1. So something like this. You see what has happened over here. You see what has happened. Y is remaining same. My y is remaining same. But what is happening to my x? Just imagine that you have pushed this function from here and here, and you have restricted it from y. So its y won't change. Nothing will change on the y-axis. In terms of x, it will grow thinner. My curve will grow very thinner. It will grow half times of what it was earlier. But its properties won't change. Its properties will remain the same. Fine? Do you get it? Does everyone get it? I plotted this on the same scale. Both of these are on same scale.
Yes, sir.
Yes,
Okay.
sir.
Okay.
ಇಲ್ಲಿ
So
ಬರಕತ್ತೀನಿ.
fine.
Yes, sir.
Okay. So now you get what the point that I'm trying to make.
Yes, sir.
What is happening
Yes,
is
sir.
you are just pushing it from pushing it along x-axis on from both sides and making it thinner. Making it thinner. Okay. The same. Okay. So so just a one more trick question for you all. So since you know this, and yeah, just one more thing to show before giving you a question. Uh, I have y is equal to f of, let me take it as, okay, sin x ही लेता हूँ, ठीक है? I will take y as sin x only. So on the same curve, I will want to draw you something else. So I have taken y is equal to sin x, I drew its curve, okay? Now I am asking you to draw the curve of y is equal to sine of x by 3, okay? X by 3. So what will happen now? Tell me. What will happen?
Pi by 6.
Pi by 6. Okay.
No, sir.
See, your A.
3 pi by 2.
Now, see, what is your A? First tell me, what is your A? Your A is 1 by 3, right?
1 by 3. Yes,
Your
sir.
A is 1 by 3.
5 by
Yes.
6.
So just think again. I am asking you, I am asking you to shrink your number, to divide your number by 1 by 3. So if you divide any number by 1 by 3, what actually happens to the number? You have a number, okay? You have a number. I am asking you to divide it by 1 by 3. So what happens to the function? What happens to the number?
It goes up
It grows.
3 into.
It
Sir.
right? It
3x.
grows 3 times. It actually grows 3 times.
Yes, sir.
It doesn't shrink. It grows 3 times. So the same will happen over here.
3
No
pi by
difference.
2. 3
Yes,
pi.
3 pi
correct.
by 2.
3
Yes, my
pi.
function will.
5 by.
Oh, sorry. अच्छा हाँ, sorry. नहीं, please correct.
3 pi.
I'm just making it on the same scale, na. I have to make it on same scale also to show, na. Scale भी तो same रखना है. Otherwise, how will you compare the two functions? You need to compare also, no, that your function has grown 3 times.
Yes, sir.
Fine. So 2 pi है, यहाँ पे अपना आ गया कितना आ गया? 5 pi by 2 आ गया. 2.5 है. Similarly, यहाँ आ गया 3 pi.
3 pi.
यहाँ पे आ गया 4 pi. यहाँ आ गया 7 pi by 2. Okay. Okay. So like I don't think we will be able to complete the function also, but no worries. So see, whatever was happening is at pi here will happen at 3 pi. So this is my 1 and this is my -1. Okay. So this is my curve, this is my curve, and so at 3 pi by 2 it will. और ये ऐसे. Something like this. So this top part has grown 3 times. Similarly,
Sir,
if I
3
try
pi
to,
or 3 pi by 2?
sorry,
3 pi by 2 or 3 pi, sir?
uh, I'm not able to understand. Can you please say again?
3 pi by 2 or 3 pi, sir?
See, at 3 pi by 2, my value will be 1. y is equal to 1, so it has to be here. And at x is equal to 3 pi, so sine of pi, it will be 0. So it is, yeah, it is correct. So basically my figure, my function has grown 3 times.
Okay, sir.
Okay. Why? Because my value of a is lesser than 1. That is why. Fine. Now I guess you will be able to do. You will be able to think basically. That is the point I am trying to make. See, the point
Yes,
is
sir.
here I was only able to draw this top part. If I have enough length of scale, I will be able to go even further also. Okay. I'm not going even further because like there is not enough space. Okay. Otherwise, like if you grow something like this, it can grow even longer. Okay.
Yes, sir.
Fine. 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 So, okay. So just one homework problem for you. Just come and think about this. I have y is equal to f of x. Okay. I have drawn its curve. I have drawn its curve. Okay. Something like this. What will happen? See, I have now taught you about f of minus x also. I have taught you about minus x also. What will happen when I draw the curve of y is equal to f of ax and my a is negative? Or rather, say f of, क्या बोलूं इसको, माइनस ए एक्स बोल देता हूँ, चलो. इसको मैं बोल देता हूँ माइनस ए एक्स and my a is positive, like something like f of 3x minus 3x, yeah, f of minus 2.5x, or f of minus x by 3, something like this. What will happen? So this is your homework just to figure out. Okay, कर लोगे ना? Okay,
Yes,
just
sir.
think about this and come tomorrow. Okay,
Sir.
what will happen? Fine. Okay, just two more classes and then we'll be over with this. Fine. Okay, yeah, that's it. Thank you. Do you have any doubt in today's class? Please ask me if you have. Did everyone understand this f of ax thing? Why we were getting x2 is equal to x1 by a, and what this meant? What was this thing denoting? It was denoting that that in order to get the same value of y, your new input will be divided by your old input by a. So your old input divided by a will be your new input. So that means your curve will decrease, will shrink by a times. But what happens if a comes out to be lesser than 1? So you are basically dividing by a, right? And my a is lesser than 1. So actually it will grow, right? We saw that in x by sine of x by 3 also. It is actually growing. Why? Because a is negative. So when you divide by a number smaller than 1, the value actually becomes larger. So that is what is happening. And yeah, just before moving ahead, if I have a function y is equal to f of x and I plot y is equal to a times f of x, so can you think, or should I directly give the answer? तो ठीक है, इसको भी सोच लेना. This one is a bit easier. Okay, so fine, that's it. Thank you. Ma'am, the class is over from my side.
Yes, sir. Yes, sir. Thank you, sir. Yes, students, again we'll meet tomorrow morning, 5 to 7. Right? So bye, everyone.